Welcome to Huawei eLearning Services. My name is Klaus Schweiger and today I will talk about SDN standards, architecture and working process. After completion of this course, you will be able to describe the SDN standards, the SDN architecture and the working process of SDN. First, let's talk about the SDN standards organizations. ONF, which is Open Networking Foundation. It's a user-driven organization dedicated to the promotion and adoption of SDN. The major focus of ONF is to provide open standards for SDN. This is considered to be a basic requirement to make SDN a commercial success. OpenFlow standard is the main development coming out of ONF. The OpenFlow standard is the first and only vendor-neutral standard communications interface defined between the control and the forwarding layers of an SDN architecture. The other big organization is IETF, Internet Engineering Task Force. According to IETF, the traditional network equipment providers need to build their own SDN architecture, because under the terms of IETF, OpenFlow will clearly favor the chip maker industry with companies like Broadcom, etc., in comparison to network equipment manufacturers. These network equipment manufacturers are considered to be the biggest losers in this competition. Let's have a look at the reference architecture of SDN. The basic concept of SDN is that it decouples the network control layer from the data transport layer. The network control layer is the layer that manages the network devices by means of signaling. The data transport layer, of course, is the layer where the actual traffic flows. For separation of these two layers, and here comes the second essential aspect of SDN, SDN uses open interfaces or standards, preferably OpenFlow, for the communication between these two layers. We also call this the southbound interface, seen from the controller's perspective. And there are applications running on top of the SDN network controller. The interface between application and controller is called the northbound interface. It is an application program interface. A protocol which may run here is, for instance, RESTful protocol. There is another layer in the SDN architecture that can sit in between the network controller and the application layer. This layer is called orchestration layer. And its main job is to allow the application to communicate with multiple controllers. So why should a carrier now use SDN? Well, because SDN provides some real advantages compared with the traditional network infrastructure. First advantage, due to its open interface architecture, SDN allows the carrier to integrate different vendors easily into its network. So it allows also a smooth integration of new network elements. This is what is meant with the expression elastic. Another advantage is that SDN allows fast provisioning and an easy integration of new services. This can be provided due to the fact that SDN architecture uses open APIs to integrate applications. This is what is called here as agile. Third advantage, simple. This refers to operation and maintenance. SDN uses also for this purpose standardized protocols like, for instance, netconf protocol. This allows a simple but very powerful integration of O&M systems. Another major advantage of SDN is called customization or value added. This refers to the support of virtualization within SDN at a very high level. It truly allows to provide and to tailor services exactly according to customers' needs. Let's have a deeper look at the major organizations which are responsible for the SDN and also NFV, which is Network Function Virtualization. And let's try to understand what are the main differences of these individual approaches. The mentioned standard organizations are ONF, IETF and ETSI. ETSI is European Telecommunications Standard Institute. Who are the participants in these organizations? As already said, ONF is a user-driven organization. There are all kinds of members like internet companies, Google, Facebook. There are operators like Deutsche Telekom, Verizon, NTT, and there are startup companies like Big Switch. IETF is more representing the traditional equipment vendors like Cisco. ETSI, it's an organization which represents mainly operators, BT, Telefonica, AT&T, Verizon, German Telecom, but also vendors like Intel or HP. What is the main focus of these organizations? ONF focuses on the SDN architecture and on the definition of the open flow protocol used between network control layer and data transport layer. IETF puts the focus on the integration of existing equipment to SDN. For this purpose, I2RS, interface to routing system, and PCE, path computation element, have been defined by the IETF. ETSI's main focus is in the field of SDN is clearly on network function virtualization, which virtualizes servers, storage systems, or network devices. A few additional commands. ONF and ETSI do have quite similar approaches. Both are generalized approaches focusing on low-cost hardware, putting less value on network devices. But nevertheless, these two approaches are not exactly the same. In general, NFV can be considered to be one of the primary SDN use cases, so NFV may be based on SDN. The IETF approach is based on a smooth integration to SDN on existing network devices. Now we want to focus on SDN seen from the perspective of Open Network Foundation. As already mentioned, one of the major principles of the SDN architecture by ONF is the separation of control plane and data plane. If we are looking more detailed into the layer architecture, we can see that ONF divides the SDN model into three layers: application layer, control layer, and infrastructure or data layer. Application layer. This layer represents an abstracted view of the network and provides configuration tools to administrators. Configuration commands are transmitted to the underlying control layer through vendor-created APIs, and the abstracted network view is updated by the control layer. The control layer represents an abstracted network view to the application layer and then translates the commands from the application layer into configuration commands for the underlying infrastructure layer. Communication in the control layer is bidirectional, so any change in the infrastructure are communicated back and displayed as changes in the application layer's abstracted network view. Infrastructure, or more often this is called just the data layer. This is the underlying layer representing network devices like switches, routers, firewalls, etc. It is configured by the control layer and sends back status update to the control layer. This picture shows the progress in the development of the OpenFlow standard. Actually, the first OpenFlow draft version was version 0.2, which was published in March 2008. End of 2009, with release of version 1.0, a basic protocol version was released. This version was widely used. In February 2011, with version 1.1, the multi-table support and packet flow forwarding through pipeline processing was implemented. end of 2011, version 1.2 came out. TLV table variation and IPv6 support have been implemented within OpenFlow standard. In version 1.3, topology discovery and test processes with test sets were implemented. In October 2013, with version 1.4, capability discovery and test labs were included into the OpenFlow protocol. With version 1.5, which was released in January 2015, the forwarding model was changed. Now the forwarding can also be done in the context of the output port. Additionally, the negotiation of device capabilities were implemented. This table now gives some more overview about the major changes in OpenFlow protocol from version 1.1 to version 1.3. First, we shortly have to talk about a few basics of OpenFlow protocol. An OpenFlow switch consists of a flow table, which is responsible to perform packet lookup and forwarding to an external controller. This flow table has three kinds of entries: header fields to match against packets, the counters to update for matching packets, and actions to apply to matching packets. Version 1.0 is based on a single table. This table supports 12 header fields, and the fourth action was just forward or discard. Version 1.1 is based on multiple table. Now we have 15 header fields, and the fourth action is expanded with group aggregation. Also MPLS is supported. With version 1.2, also 36 header fields have been supported, and scalability plus IPv6 basic header have been implemented. Finally, version 1.3 supports now 40 header fields and also supports IPv6 extension headers. Let's have a look at the application APIs and network APIs. In general, APIs are defined for the communication in between application and the network controller. Application APIs run between app and SDN orchestrator. Network APIs run between SDN orchestrator and network controller. According to IETF, APIs may have many forms according to their specific requirements. Examples for APIs are shown in this picture. We may have APIs based on RESTful protocol, or we may have APIs based on XML. But APIs are not limited to that. Also, we may have JSON or other existing interfaces we may use to pass messages on from application to the controller level. One of the principal ideas of SDN, also seen by IETF, is to provide open APIs for network devices. This means open north and southbound interfaces supporting user innovation, but also to reuse existing interfaces. Here we can see a couple of more interfaces and protocols which can be used to communicate with existing routers and switches. PCE, which is PCE Communication Protocol, is a visibility and control protocol that works in MPLS networks and partially removes the control plane from head-end routers to define network paths. PCE, even it hasn't got the publicity or support of OpenFlow, is likely to play a role in emerging SDN architectures, especially in service providers' network. I2RS, interface to routing system, may run between an ALTO server, which stands for Application Layer Traffic Optimization, and a SDN controller. An ALTO server in this context may cover an entire carrier's network. The preferred protocol for communication with a policy controller is Diameter protocol from IETF. Traffic monitoring can be performed by NetFlow protocol. Integration of a network management system can be done via XML, via SNMP, or a proprietary command line interface. Let's have a short look at SDN standards organizations working groups. In IETF, there are quite some working groups. For network overlay, there are NVO3, L2VPN, TRIL, which is transparent interconnection of lots of links, Layer 3 VPN, there is Lisp, there is PWE3 working groups, and others. For standardization of APIs, there is NetConf, Alto, CDNI, XMPP, SDNP, I2AAX working groups. And there is working groups as for network controllers. There is PCE, Path Computation Element, 4CES, and Control Element Separation working group. And on the ONF side, there are 4 technical community areas: operator, services, specification, and market area. Some more organizations beside ETSI, IETF, and ONF, which are active on the field of SDN standardization. There is IEEE, for instance, with the 802.1 overlay network project, and some Cisco innovations based on 802.1 standard, like Cisco Fabric Extender FEX or Cisco Nexus 1000V virtual switch or vSphere from VMware. There is CloudStack, which has developed an open source cloud computing project. There is OpenStack, which is a free and open source software platform for cloud computing founded in 2010. Right now, more than 500 companies have joined the project. Neutron, which is an SDN network project from OpenStack describing networking APIs, or Donabi, which is a multi-tier application container service and a top-level orchestrator that can deploy complex apps. Again, Cisco has developed some innovations here like OpenStack API for Nexus or some other OpenStack extensions. And finally, ONRC, which is the Open Network Research Center at University of Stanford in California. How can bring together now SDN approach of IETF and the SDN approach of ONF? Well, IETF orchestrator, which can be seen as a centralized controller, can be used for intercommunication between management plane and control plane. Management plane consisting of management software including stations, agents, etc. Control plane consisting of master software, routing protocols, MPLS, ORM mechanisms, neighbor discovery, and so on, is responsible for device control. ONF, OpenFlow, can be used for intercommunication between control plane and data plane. Data plane consisting of line cards, ASICs, NP or reconfigurable data planes, so-called FPGA, and other hardware responsible for packet forwarding and switching. This picture now shall give an overview about the activities of Huawei in the SDN standardization groups of ONF. Huawei's activities are highlighted in red in the Chipmaker Advisory Board called CAP, in the migration group, and also for Open Transport Working Group. All here, and this is just a very short look, and on many more fields Huawei is playing a key role in SDN standardization. Also, Huawei was actively promoting the standardization of SDN on the field of ETSI. So, this course was focusing on Huawei SDN and gave an introduction about SDN standards, SDN architecture, and SDN working process. Thank you for watching.